So I introduce myself. I am Carl Marcelino Beni from the International Maritime University of Panama. Today, my partner and I will talk to you about gas carrier. Of the next point will give you the introduction of the topic. Gas carrier are vessels destined specifically or for the maritime transport for liquefied gas and involved in main function is to safely and efficiently transport large volume of the gas source and liquefied natural gas LNG, liquefied petrol gas LPG, ammonia, carbon dioxide, and the other industrial gas. The importance of this shift live in the growing global demand for gas as source of energy and raw material. Maritime transport allow the gas to be moved from production regional to the consumption center in the economical and practical way. Gas carriers are essential to maintain the energy supply net of many industrial around the world, handling cryogenic and load and flammable gas. Carry significant challenge and reach this vessel must meet strict safety standard and be designed to minimize the risks of the left fire and explosion. In addition, the must warrant the maintenance of the adequate temperature and pressure condition to keep the gas in the liquid state during transport. The first gas carried day back to the minimum 100 degrees Celsius when they were developed to transport LPG. Over time, the technology evolved to allow the transport of the LNG and other gas cryogenic and temperature below minus 100 degrees Celsius. Today, gas carriers are highly especially most complete with strict international regulation set by body such as the International Maritime Organization (IMO).
Design and construction. The design and construction of gas carrier is governed by special consideration to ensure the safe containment of liquefied gases at extreme pressures and temperatures. These vessels usually have a double-layer hull with an insulation space between the inner and outer layers to provide greater protection and thermal insulation. There are different types of hulls and structures for gas carriers. Membrane hulls consist of thin stainless steel or aluminum members, insulate and support by a reinforcing structure within the inner hull. They are suitable for transportation of LNG. Independent share hulls. Independent spherical tanks insulate and support within the inner hull. They are mainly used for the transportation of LPG. Independent press hulls. They have independent rectangular or cylindrical prismatic tanks, insulate and support within the inner hull. There are also to support LPG. Material used in construction must be resistant to low temperatures and corrosion, such as authentic stainless, steel, aluminum, and composite materials reinforced with glass or carbon fiber. Special welding and insulation techniques are used to ensure the integrity of the cargo tanks. Terminal insulation is crucial to maintain cryogenic cargo temperatures. Low thermal conductivity insulation foams are used, such as polyurethane or perlinen, as well as vacuum systems and low conductivity material such as perlite or fiberglass. In addition, gas carriers have ballast and stability system to compensate for weight of the cargo and maintain the stability of the vessel during loading and unloading operation. The construction of these vessels is carried out in specialty shipyards, following rigorous manufacturing process and integrity tests.
Gas carriers are equipped with fire-insulated cargo that designed to maintain gas in liquid state and cryogenic temperature. This tank can differentiate depending on the type of hull. Cylindrical common in vessel with membrane or independent prismatic hull. Spherical used in vessel with independent shape of hull. Prismatic employed in vessel with independent prismatic hull. Cargo container system also vary. Self-supporting tank. The tanks are completely independent of the hull and supported by an internal structure. Membrane tanks, seam membrane are adhered to and supported by the inner hull. Semi-refrigerated tank, a combination of insulation and refrigeration system, is used to maintain the required temperature. The pitting and valve system allow for the control loading and unloading of the liquefied gas. These systems are designed to minimize leakage and maintain the proper pressure and temperature. Key components include manifold, lowering arms, cryogenic valves. Additionally, we have vapor recirculation and handling system before starting operation are pre-cooling in the carrier up.
Downline operation. Connection of the discharge arm to the sheet collector. Control transfer of liquid gases from the sheet to the receiving terminal. Gradual increase in the pressure in the tank to facilitate unloading. Constant monitoring of level, pressure and temperature. Management of vapor generated during discharge. In addition, car assembly and analysis operations are carried out to verify its composition and quality before and after transportation. During all operation, it is crucial to maintain the stability of the vessel, carefully controlling the distribution of weight and movement of liquid cargo. The whole structural integrity management system continually monitor and the formation or exercise stress, preventive and corrective maintenance. plans are essential to ensure the optimal operation of a critical system, such as tanks, pipes, valve and control system. Other important operational factors include the speed of the vessel, the plane route, weather conditions and local regulation at loading and unloading ports.
Safety is a top priority on gas carriers due to the risk inherent in transportation flammables and cryogenic gases. Rigorous risk prevention measures are implemented. First, we have leak detection system, sensor and continuous monitoring equipment to detect any gas leak. Then we have inerting system, introduction of inert gases into gaseous spaces to avoid explosive atmosphere. Next, we have strict maintenance procedures, regular inspection and maintenance of all critical systems. Fire detection and extinguishing systems are essential, including water sprinkler system to cool and control possible fires. Next, we have firefighting foam system, application of fireproof foam in specific areas. And finally, we have self-contained breathing apparatus for emergency personnel in case of fire or leaks. In addition, the use of appropriate personal protective equipment is required, such as cryogenic suits, masks, and gloves resistant to extreme cold. Gas carriers must have detailed contingency plans and emergency protocols for different scenarios, such as leaks, fires, collision, or groundings. These plans include evacuation procedures, emergency response, and coordination with port and maritime authorities. They must also comply with international regulations such as the International Liquefied Gases and Bulk Code, SOLAS, and MARPOL.